I'm sure you people are listening me well. And now recording I have started and our topic will be the movement of a force. We have already idea about this force and now we will be discussing movement of a force. First of all, quickly, what do you mean by force? Push or pull is a force. Push or pull on an object is a force on an object. What a force can do? Force can do in general three things. Force can change the speed. It can, if we apply a force, if we apply the force which is on a force on an object, so the force can cause the speed of the object to increase, moving object, and it can cause the speed of the moving object to decrease. Example is pushing on accelerators of a car, accelerator of a car, and pushing on brakes of a car. So increase and decrease in the speed of a moving car. So that's what first thing we can say force can do. Secondly, what a force can do, force can uh, change shape or size. We can compress, we can stretch the body by applying a force. Size and shape. Also, force can change direction. Also, force can change direction. So, like we apply a force on the steering wheel, and as a result, direction is changed. It can make take a left turn, it may take a right turn. Okay, now the movement of a force. It is the turning effect of a force about a pivot or hinge. It is the turning effect of a force on a pivot or a hinge. Now in this case you can check this one, this nut, steel nut, this is a pivot and this spanner can be turned about it. Now this force which is responsible to turn this steel nut, it is movement of a force. And other very best example of this uh, steel nut is, sorry, this movement of a force is that it is the door, opening of the door and shutting of a door or a gate, that is completely specified or completely following the definition of movement of a force. So I have to give you many examples on this, so stay connected. But I need 1 minute so that I can contact the chemistry teacher of my daughter, because she is trying to join from a new link, new device, and he is not maybe not knowing, so he did not let her join still. So just give me a moment and then I will be back. Okay, my dear students, actually she has to take two subjects now in October series, math and chemistry. So her chemistry class she is going to join, and link was not there. Now it is done. Okay. So another example, the best example to understand the movement of a force, that is opening and shutting of a door. So we can see when we open the door, it's not in a straight line, it is just turning like the pie, a piece of pizza. When you cut the pizza in 4 or 8 pieces, so it is just like pizza ki piece of pizza, so like that stuff. So this is a turning effect of the force. Similarly, when we are unscrewing the steel nuts from the, or metal nuts from the tires of a car, of any automobile, so we are using a spanner. So when we are applying the force, that force is not making the steel nut or any metal nut to move in a straight line. No, it turns, it turns it either clockwise or anti-clockwise. That is another example of what movement of a force. So a lot of examples we can consider, and questions we will be also solving on this one, so don't worry at all. So first of all, it is the turning effect of a force about a pivot or a hinge. Pivot, I can show you the example here right now, where they see a wrestler and a small girl is sitting. This is a pivot, like a seesaw in a park. And in this case, this one is the pivot. Another thing, just stay connected with me, and I will share with you something, like I am moving it close to my door where I am sitting, so you can see this one now. There are some hinges or pivots here also, even on this door. One side is the handle side, one side is what, that is the side of a handle. Now you can check here, this is the door, here is the handle, first of all, to open it, to shut it, and on the other side here, check. Now my dear friends, here is my hand, this is the hinge, and there are 1, 2, 3 and 4 hinges on this door. So see, when applying force on this pivot, so this is making, oh sorry, on this handle, so there is a turning effect caused by this force, so that's why we call it movement of a force. So to understand what is the hinge or pivot, so this is the hinge or pivot where my hand is touching. So you can check on every door, this thing is available. Okay, this is the first thing. Then my dear friends, next is, so it is the turning effect of a force about a pivot or hinge. It is a vector quantity that has both magnitude as well as direction, because for vector quantities there are two things needed. One is the magnitude, another one is the direction. One is magnitude, another one is what, direction. So magnitude and direction. So direction, how? Whenever we talk about the movement, it has two directions, either it will be clockwise or it will be anti-clockwise. Now clockwise and anti-clockwise, I will be making it very clear. Just give me a moment, I will be explaining it in next few minutes. So how to calculate the movement of a force? This is very common question in paper 2 as well as in paper 4. Paper 6 also it is coming. Paper 6 also it is coming, but it is there is no calculation needed, just the data is given and we are plotting graph or reasoning and like this stuff. Anyhow, so this is also the topic. Let me tell you, this movement of a force, very important. Last time I was having short time, so I did not explain, I did not start it intentionally because I need a lot of things to discuss with you. So this is one of the topics along with Hooke's law from this topic chapter, we can say from this booklet, Hooke's law and this movement of a force, which is very common even in paper 6. Paper 6 have some limited topics and this is one of them. So to calculate movement, formula is force times distance. Now, but there is something. Now see, movement of a force is equal to force times distance. We cannot say only force is equal to force times distance. How come? It is always movement of a force which is equal to force times distance. Here F is the applied force and D is the perpendicular distance from the line of action of the force to the pivot. Very important. Now listen. What do we mean? Where D is the perpendicular distance. How it is perpendicular distance? See, this is the distance and the angle between the force and distance is how much? 90 degree. Always we are dealing with perpendicular distance while calculating movement of a force. Line of action of force. See, force is acting here. So this red one is the line of action of force to the pivot. SI unit for the moment of force is Newton meter. Why Newton meter? Because moment of force is equal to force times distance. So force times distance. Force is measured in Newton and distance is measured in meters. So the unit of moment of force is Newton meter. So the moment of force is a vector quantity. It may be clockwise, it may be anti-clockwise. To explain this, first of all, just imagine the dial of a clock, wall clock. How is that? In general, 12, 3, 6, 9. And rest of the numbers are in between. So minute hand, let me say this is a minute hand. Here is the pivot. So if the minute hand in general, not if, minute hand is always moving this way, mean its direction is this way. So this all is what? Clockwise, 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 clockwise. But if something is in opposite direction, how opposite direction? Let's suppose this way, arrows are reversed. This way, this is ACW, anti-clockwise movement. So clockwise, anti-clockwise. Now for understanding, this is from clock and we are applying it. For better understanding, now let me tell you that it is about, if you are driving a car and you are going to make a right turn, that will be the clockwise motion. How you will make a right turn? Now just observe. I'm going to drive. This is steering wheel in my hand. So how clockwise? In this, center is the pivot. The steering wheel is into the body of the car and connected to the engine and all these things mean. So see, my right hand going down, left is going up. So if the force acting on the right side of the pivot, downward, clockwise movement. On the left side of the pivot, upward, also clockwise movement. So when we are making a right turn, by using the steering wheel of the car, that is clockwise movement. That is causing clockwise movement, or the force is causing clockwise movement. But if you are making a left turn, now right hand side force upward, left hand side force from the pivot downward. So it is making what? Left hand turn, and this force is causing anti-clockwise movement. Anti-clockwise movement. Now I'm going to apply the same thing on this boy and girl. Of course, the weight of their body is acting on them. Let's suppose the weight is always, vertically downward. So weight of this young man vertically downward, and the weight of the small baby girl, let me say, that is also downward. Now see, if you observe it, please, if you observe it, this one weight, this is downward and it will make this plank to turn clockwise this way. See, this direction is what? Clockwise direction. But if I'm talking about the girl, she is sitting on the left side of the pivot, so she is causing the clockwise, anti-clockwise movement. See, her weight will make the plank to rotate anti-clockwise. So what I'm telling to student to memorize them all the time, that first of all locate the pivot. First of all locate the pivot in the question, then all the forces which are acting on the right hand side of the pivot and they are downwards will cause clockwise movement, and all the forces which are acting on the left side of the pivot but downward, they will cause anti-clockwise movement. Again, forces on the right side of the pivot downward, clockwise movement. Forces on the left side of the pivot downward, anti-clockwise movement. If the forces are acting upward, then think opposite to that. What do we mean by this? See, if a force is acting up there and a force is acting up there, this force will cause clockwise movement and this force will cause anti-clockwise movement. Right now, this force is causing clockwise movement and this one force is causing what? Anti-clockwise movement. So downward clockwise on right side, downward anti-clockwise on the left side of what? Pivot, and upward you have to think in opposite fashion. So this is very important to solve the questions in exam, so remember them. Just one thing more I have to share. If the examiner is saying that this this plank on which this boy and girl are sitting, it is turning clockwise, it means that clockwise movement is greater than anti-clockwise movement. And if the statement is that the plank is turning anti-clockwise, it means the anti-clockwise movement caused by the weight of the girl, it is greater than the clockwise movement caused by the weight of the boy. Please now read specially from here till here, observe these diagrams, and if there is anything you want to ask, please feel free and ask me. Waiting for your response. Okay, let me see. Donna, there is one comment. No, this is nothing. This is just an example. This is just an example, and they will ask you, they will tell you in the question it is clockwise or anti-clockwise. In general, for it to be an equilibrium, Yusuf, for it to be an equilibrium, it should be such that clockwise is equal to anti-clockwise. That is coming in the next explanation. Now, let me move forward, and the topic is equilibrium. This is same, continuity is there, but just wait. A body is said to be in equilibrium if it is at rest or moving with uniform velocity. In both the cases, acceleration is zero. So if the body is in equilibrium, so two possibilities are there: or the body is at rest, either the body is at rest or it is moving with uniform velocity, or it is moving in uniform velocity, which means zero acceleration. So for a body which is at rest, we will say body is in equilibrium. For a body, if you have set the cruise and car is on a straight line, straight road, and I shared with you in the previous lesson, right now the world record is with Saudi Arabia, that it is connecting 200 plus kilometers to places, Alatul straight line without any bend. So when your car is on that highway for at least 200 kilometers, if your speed, you have set the cruise like 120 kilometers per hour, so your car is going with uniform velocity, in other words zero acceleration. A body is in equilibrium. A body in equilibrium must fulfill these two conditions. What are the two conditions? The forces on it must be balanced, no resultant force. Forces on it must be balanced, no resultant force, or total upward force is equal to total downward force. Now, my dear friends, all of this is correct, but you know, this one is helping us a lot in the solution of a lot of questions. I will solve inshallah today. So, total upward force is equal to total downward force. This is first thing. Secondly, total or the moment of force on it must be balanced, or no resultant moment of force. Or we can say total clockwise movement is equal to total anti-clockwise movement. This will also help us a lot to find many numerical problems. So these two things which I have circled, you must be memorizing. Now, mostly in exams, these things which I have circled, they are recall memory. What do we mean by recall memory? In general, it is believed that 30% of Cambridge exams for IGCSE physics, it is consisting of recall memory. Recall memory, just memorization, recalling back the definitions, rules, equations, something like this. So this is there. They are asking in general, write two conditions for a body to be in equilibrium. So you can write forces on it must be balanced, or no resultant force, or total upward force is equal to total downward force. Any one of these three statements for first mark. For second mark, the moment of forces on it must be balanced, or no resultant moment of forces, or total clockwise movement is equal to total anti-clockwise movement. But if the examiner is saying the body is not in equilibrium, what can be the reason? So you can say total upward force is not equal to total downward force. This is in case if the examiner is saying that the body is not balanced, not in equilibrium. So equal will be replaced by not equal. These are the two conditions for a body to be in what? To be in equilibrium. Okay. So please read these few lines, and if you have any query about them, ask me first. Waiting for your reply. Okay. Center of gravity. It is the point at which whole weight of an object seems to act. Mean, this is the point where whole weight of an object is concentrated, is acting. Now, if a body is supported at its center of mass or center of gravity, not, you know, center of mass and center of gravity, same point. Center of mass, or you can say center of gravity. It stands still without any rotation. For regular shaped, for center of mass or center of gravity of regular shaped objects is at their centers. For example, the center of gravity of a uniform meter rule, which is 100 centimeter long, is at 50 centimeter mark. Is at 50 centimeter mark. Very important to understand this concept, and I will be just performing it in front of you right now. Scale. Okay. Now see here, my dear friends. First of all, I will do it with a scale. Now you can check. You can see in my hand, I am holding one scale. This scale is 30 centimeter in length, and this is a regular shaped scale. This is what? This is a regular shaped scale. It 30. What is the center of 30? That is 15. So now see, if I'm supporting it at 15 centimeter, see, it is standing still, not rotating or overturning. Why so? Because I am supporting it from a point which is at its center of mass or center of gravity. So that's why for regular shaped objects, their center of mass is at their center. Now I will try to do it with my mobile. This is also a regular shaped object, okay, like a rectangular cube. So here I need little bit more time because its length is not marked. So roughly I'm supporting it at the center. Still no, I did not find no right now. See, my thumb is pointing or supporting this mobile at one point, and the point right now my thumb is supporting this mobile. This point is the center of gravity of this mobile, and mobile is stable over there. Even same point is the center of mass. So what will be the definition in exam? Actually, center of mass is removed, center of gravity is there now with you, with us from 2023. But if there was a definition of center of mass, how can we define? It will be that it is the point at which whole mass of the object seems to act. Only the whole weight will be replaced by whole mass. Rest everything is same. So see, I'm teaching you, talking to you, and my thumb is supporting at one point of this mobile, and that point is the center of gravity, and it is no more toppling, it is stable, it is in equilibrium. See, so this is the concept of center of mass for regular shaped object. Now what about irregular shaped object? First of all, if you have any question regarding the center of gravity or center of mass, so please you can ask me and read these lines, and after that I will share with you one video. It will be you will be watching it live with me, and that will be explaining the center of mass of irregular shaped object like lamina, like this shape down you can see. But before that, please read this all. If you have any question, feel free and you people can ask me. A lot of questions we are going to solve after this. A lot of questions. Okay. Now center of mass or center of gravity of irregular shaped object. Center of mass or center of gravity of irregular shaped object. See, center of gravity of an irregular shaped object can be found using a stand with a clamp. Make the small holes A, B, and C equally spaced corners of the lamina. This diagram below shown shown below. Irregular shaped object is known as lamina. Hang the object at the pin from hole A. You can check here. It is hanging from hole A. Alhamdulillah. The plumb line next to the planar object, this ball with a string, this ball with a string attached to a string, that is plumb line. It is simply not ball, actually it is a body of heavy weight with small mass, mean concentrated cylinder, concentrated ball of metals, one end attached to the string, and then it when it is suspended from some support, it hangs vertically downward, so that is plumb line. Put a mark A dash on the planar object where the plumb line passes through at the bottom. Now see, this is A, so this line I can mark as A dash. Then repeat the procedure for the hole B and C. See, here is B, so this will be B dash. This is A dash. See, A dash, B dash, then hang it from C, so this will be C dash, and you can observe that all of these three lines, they are intersecting at one point. So the intersecting point of the three lines will be the center of gravity of the irregular shaped object lamina. Please, this is something which will be difficult to know, sir, what you have said, how it will be performed. Just wait, I am sharing with you a video. Just a moment. I am sure screen is directly shared with you. This is hardly 2 minutes video and screen is being shared with you.
Center of gravity. Try balance.
Okay, my dear friends, can you see the video, please? Is this screen shared with you? Yes, it is shared. And can you hear it also? Voice is clear to you or no?
On your
Yes.
Yes. What do you observe?
Now see,
We
that's
observe
what
that there is
I was
only
sharing with
one
you
point
people,
on which
that
the
a
cardboard
cardboard
can be balanced.
is supported at
This
one point. The
where
point is the
cardboard
center
can
of
be
gravity.
balanced is called the center of gravity of the cardboard. Thus, the center of gravity
is the point through which the resultant of the weight of all particles of the body act. So resultant means total, where whole weight of the object is acting. In simple word, that's what I wrote in the notes.
Let us now determine.
Now we are trying to find the center of gravity of irregular shaped object. This is a stand. Now PQR. In notes I wrote ABC. Here they are using PQR.
The lamina can swing
Three holes are
when pivoted from each
made.
hole. Suspend the lamina
Now,
from the point P as shown
it will
here.
oscillate for some time and then will become stable. Now plumb
From
line.
the point P and mark the plumbing line.
Now
P,
this
P
plumb
dash
line will
on
be
the
P
lamina.
dash.
Repeat the experiment
It will be
by
repeated
suspending
with
the lamina from
point Q, hole
and
Q.
mark the plumbing line Q, Q dash.
Now the same thing will be repeated for
Now follow the same procedure
gap R.
for the point R. We observe that all the three
Now see,
lines,
all the
PP
3
dash,
points, they
QQ
are
dash,
intersecting at
and
one
RR
point.
dash
That is the center of
intersect
gravity
at one point.
of an irregular
This point
shaped
where all the
object.
three lines meet gives the center of gravity of the lamina.
Now my dear, just a minute. Again go back. Now please, my dear friends, read these points again, and if it is still confusing, I can go back to the video, but read it now. It will be making more clear. Please, it will be giving you a more clear concept. Waiting for your response, quickly do it. Yeah, my dear friends, you have to read this one. Center of mass or irregular shaped object. Read it just once. It's not visible to you. I can stop share and again share and check. If it is still not visible, then leave the class and then join me back. Okay, good. Now we will be moving forward. Next is stability. Now definition of stability is a measure. Definition, by the way, they are never asking, but we cannot say that they can never ask, they may ask, so that's what I have written here. Is a measure of how likely it is for an object to topple over when pushed or moved. An object is stable when its center of gravity lies above its base. Now you may be thinking, sir, what is this? Now come, there are two diagrams. Now my dear friends, these both diagrams are representing these two lines, this one or this one. Now see, this object, this is stable, and this one is unstable. Now how? See, if I'm pushing, and you can see it, you can see it. See, even this glass on my hand, its base area is more on my hand. If I'm pushing it forward, again it comes back to its original state. See, I'm pushing it this way, again comes back to its original state. So this glass is stable because more, and its center of mass or center of gravity lies through its base. But if the glass is already something like this here, so I will just remove my thumb and it will topple. It is toppled. The reason is, see here, this center of gravity lies on its base. Base is here and center of gravity is out of the base. So that's why second diagram is unstable. Now come here again. Stability is a measure how likely it is for an object to topple over. Topple over means, like you can, like cars toppling over in a crash or like these things. So just overturn when pushed or moved. An object is stable when its center of gravity lies above its base. Like in the first diagram on the left hand side, the cross represents the center of gravity line. So it lies on the base. It is stable. In the second case, the center of gravity lies out of its base. So that is unstable. This is about stability. Now it will be further explained. Stay connected. Okay, the factors on which the stability of an object depend. Factors on which stability of an object depends. The base area of the object, that affects the stability. Then the height of the center of gravity above its base. So these are the two things. How these two things are affecting, now come here. To improve the stability of an object, we can increase the base area of an object. Increase the base area of an object. Second thing, add weights to the base of the objects such that the center of gravity becomes lower, closer to the ground. So now you can see this conical object, it is stable. Why? It's having a wide base area. Secondly, so base area is wide. Secondly, its center of gravity is closer to the ground. So it is more stable. If I'm toppling it, making it upside down, like you please see this one. Now center of gravity mumkin here. So base area less and also center of gravity higher. So this object is not stable. It is not fulfilling the definition of stability. Because no need to topple it. Even this is diagram, so it is standing like this. Otherwise, if I'm putting this cone upside down, it will not be standing vertically upward. It will just topple either right, left, forward, backward like that. The reason is base area is very less. Secondly, its center of gravity is higher. Most of the mass is shifted up. This is about center of gravity. Now I would like to share with you people some examples from daily life. Nowadays athletics are going on, and few days back, I think yesterday or day before yesterday, a very hard worker girl. She's from Algeria, I think, or Nigeria. She won the gold medal in boxing, girls boxing. Now, my dear friends, when a boxer is in the ring, either male or female, they are never standing straight. They are standing by keeping their legs far apart. Try to understand me what I'm saying. In general, when you are standing, like my fingers are pointing as legs, you are standing like this on the ground. A little small difference between your feet and your legs vertically. But if you want to get more stability, just move your legs far apart like this. Check now. So when you will do like this, your height will be decreased. So center of gravity will become lower and the base area will be increased. You will be more stable. That's why the boxers, famous boxers, professionals, when they are in the boxing ring, they are never standing in a normal situation on your feet. They are moving their legs apart little bit so that the base area is increased and their height is little bit less. Just imagine, you can do it even while the lesson. So stand up, check your normal way to stand, and then move your legs far apart. Your height will be decreased and your base area will be increased. Both of the conditions of the stability will be achieved and you will be more stable. That's what I was supposed to do in my childhood, that when we were traveling in buses like public transport in my country, so if the bus is on a bumpy track and you are standing in the aisle of the bus, mean here are the seats to sit, here are the seats to sit, in between there is a passage. So you are standing in the passage, like in aeroplanes we are calling it AISLE aisle. So you are standing there, nothing to hold. So if the bus is on a bumpy track, so how can you be stable? So just move your legs far apart. So what will happen? Your base area will be increased, your height will be decreased. In other words, your base area will be more and center of gravity will become closer to the ground and you will be more stable. First example. Then many examples. You can check all the skyscrapers like the Burj Khalifa. Here even in Riyadh Faisalia. All these uh, top high-rise buildings, they are made on the same concept like this tiger, like this one. That from the ground, first of all, they are not built just from the surface of the ground, from the ground surface ground. They are digging the ground deep and then placing their concrete and steel and a lot of things, and then as it is rising up, so its height is decreasing. Its height is what? Its height is, sorry, its thickness is decreasing, like Faisalia, Burj Khalifa, Eiffel Tower in Paris. Nowadays Paris is very famous because is in news because of the these Olympics. So base area more, and it is getting thinner and thinner at the top, such that center of gravity is lower. With greater base area, things are stable. You have seen Formula 1 racing cars. You have seen what? Formula 1. Formula 1 racing cars. How they are? Even German cars like BMW, Mercedes, and you can compare those car tires with Corolla or Hyundai Accent. So you will observe the car wheels or tires of BMW or even Audi from Italy. All these cars, they are having wide wheels, and heights are comparatively lower. So they are very stable cars while they are on the ground, while they are on the road, running at very high speed. Even about one of the series of BMW, I know that in hardly 3 to 4 seconds, it is reaching to a speed of 100 miles per hour in few seconds. So very strong, very stable. The reason, they are following the stability concept. Then Formula 1 racing cars. Formula 1 racing cars, if you don't have an idea how they are like, or they are how they are more stable, so just observe this image again. I will be writing here an image of F1 cars. Now see, a lot you can see here. A lot you can see here. Now even just let me share with you this image in detail. Now see this car, this is a model by the way, its height is very less, okay, and see the wheels, they are very wide. That's why these drivers, like when they are on this in the circuit, mean around track and like this, so they are running their cars at really high speed and no turtle turn or toppling over, because they are stable, height is less and wheels are wide, so tires are wide, more base area, and see their shape spreading. Check their shape, that shape is not you can say concentrated like compact, no, it is spread like this, it is spreading over over more area, so increasing the base area, height is low, center of gravity is lower, or in other words closer to the ground, and these cars are much stable. Now the last example, or two more examples to make it further clear. Another example, first of all, let me say a glass of juice. A technical name for this is goblet, I think. See, and don't worry, my diagram will not be exactly the same size. Two diagrams. This is a juice glass, goblet, its name. Another one I'm also making. And the size are same. Okay, don't go with my diagram. They are the two same glasses, same dimensions. Once it is empty, when it is empty, just let me tell you, and you know this stem to hold this glass, that is bit strong. So when this is empty, center of gravity is over here, closer to the ground. Okay, if you put here, let me write here, orange juice, so it is filled with orange juice, same glass, no, center of mass is shifted up. Why? Because most mass is up there. Now maybe center of gravity is here. Base area is same. I am calling this one as A and this one as B. Now everybody is supposed to answer me which glass is more stable. Okay, A and B, they are having the same base area, like both are having 0.25 meter square. Base area for A and base area for B is same. So from looking at the height of the center of gravity, which one will be more stable, A or B? Waiting for your response. Hurry up. I want everybody to respond. Yusuf correct. Ala correct. Abdurrahman correct. Sareen correct. What about others? Quickly, quickly, my dear friends. Rafif correct. Okay. So Amru did not answer. Ahmad did not answer. Please quickly answer. Amru and Ahmad. A or B? Which one is more stable? Okay, my dear friends. So of course, more stable is, oh, which one is more stable? All of you are wrong. Correct answer is A. Why A? Sorry, everybody who said B, they are wrong. I myself forgot. Why A is more strong? Check second condition. Add weights to the base of the object such that center of gravity becomes lower. Now here center of gravity is lower. When some load is attacked, juice is placed into the same glass, so a lot of mass is shifted up, so center of gravity rises, it becomes less stable. Please try to understand this, it becomes less stable. If I ask you which one is less stable, then it is B. If I have asked you which one is more stable, then it is A. To explain this, you did not ask, but I am remembering that in almost every lesson, every session, when I'm teaching this topic, boys are asking me, sir, okay, you are giving the example of Eiffel Tower, Burj Khalifa or Kingdom Tower, Faisalia. What about Kingdom Tower? It goes alatul straight up from the ground till the top. Yes, but there is also this rules followed, and this explanation now make this question also very clear, which I was asking you people. You just check the shape of this Kingdom Tower. Kingdom Tower is shaped in Riyadh. It is shaped like this. at the top like this. Now you have observed there is like something like this here at the top. My dear friends, yes, if you are traveling along the King Fahd Road even towards north or towards south, you will see its thickness is same. But if you are moving from Hayal Safarak, mean from Diplomatic Enclave side towards King Abdullah Road, King Fahd Road, sorry, or from Abu Bakr Siddiq Road towards this Ulayya, so you will see that at the bottom it is thicker. It is thicker from here, and at the top it is thinner, so more mass is attacked at the bottom. And second most important thing, see the top of this tower here, it is empty. Empty means there is only air, and air is less dense, air is having less mass as compared to glass or other solids. So at the top there is less mass. It means the center of gravity of this building is closer to the ground. So that's why this kingdom tower is stable. Please think on this, and also then consider this answer A for more stable. And if there is doubt, ask me again. Waiting for your response. And before that, I forgot 1 to 2 points regarding this moment of force. Remind me, I will be solving them in this. I will be explaining you after short break. But right now, please consider and let me know, did you understand this or not? Did you understand this or not? I'm willing your response. I'm willing to know your response right now. Okay. Now, my dear, wait a minute. I will give you 5 to 7 minutes break. Okay, and then I will come back to this point and I will re-explain it all. So till that time, now just a short break. Maybe you people are tired, and right now 6:04, so I'm writing here because I will start from here. Break till 6:12 p.m. and then we will start again. Okay, so I'm stopping the recording. Don't go anywhere. We will restart again from this at 6:30 p.m. inshallah. Stay blessed all of you.